Okay, so sorry, I am uploading these as I go along. So this is part 3. So we've loaded the data, and if we print the numbers, okay, this list, it gives us the full list of all these numbers. All right. So the issue here is that in my example, what I would like to do is have this number map onto whatever the size of these are going to be. And my ultimate idea is this would be a full screen thing. So right now they're kind of stacked in here because this is a little smaller, 800 by 800. But certainly I can't have an ellipse in my screen that's 52,000 pixels. We're not going to see it. So what we need to do is filter it or remap those values. So what we could do is grab any one of these values and we can say, well, the old minimum and the old maximum of the range of numbers, we're going to take those and remap those values. So it's like saying from, well, in this case, 50,000, okay, and the upper thing. So in this case, it's very simple. I could just look in here and find these numbers and use them. Sometimes when you're using data, the whole point is they're huge data sets. So you want processing to do the work for you and find these out. So what we're going to do is create a new variable so we can figure out what those min and max are without having to do this manually. Because if we had like a series of spreadsheets, we wouldn't want to go and hunt them all down. And then we're going to create a new for loop where we're going to load the number and then remap those values to something that fits what we want the size of our bubbles to be. Okay, so the way we do this is, this is a pretty standard kind of thing when you're dealing with numerical data and these sets, is that the range of numbers you need to transform, do some logarithmic scale or something so that they fit the framework that you need. So I'm just going to create 2 new variables. I'm going to call one the number max, okay, and that is going to equal this new little method here, the maximum value that's in the list of numbers called the numbers, or the number, right? And then float, and we're called min, and this is going to be the minimum of whatever that value is from that list, or number. Okay, and we can test it if we want. We could say print num min. Okay, we were looking at the bottom right there, so it should say 50,000. Okay, all right, so that's working for us. We're moving right along. So the next thing is to go through and load each one of those numbers and remap those values. So what I'm going to do is just copy the for loop. And we don't need to do that. We've already done that. We are going to use the numbers, but what we're going to do is grab each one of the numbers. So the way this works is we're going to use a map function. Okay. So the map says, let's just go to the reference. And we'll just find map. And not hash map, but a map. Okay. Oh, not max. We want map. Okay, there it is. Remaps a number from one range to another. Okay. So the first value is the incoming value. The lower bound, so the old min, the old max, and then the new min, the new max. So the first thing we're going to put in here is the number. Okay, so whatever is in that list, so the first one, the second one, the third one, and we're going to say whatever the numerical minimum in that list, and we're going to maximum. And right now we're just going to guess. So let's just say 10 and 400. Okay. And see if we get any errors. Okay, so no errors. Everything seems to be working. So you can, this might seem a little odd, you can say this current number is going to equal whatever the current number is after it's been remapped to this value. Okay, so we take this current thing, we remap it, and then we make it equal to, we like replace it within that list. Okay. And the one thing in doing this, you're like, why did we do a couple for loops? Well, the first problem is that as we were loading the list and we get the new minimum and maximum, but then if we did the same operation in here, it would change what the possible min and max is for the second and the third time that was around. So really you'd end up with the exact same number the whole entire way. So we needed to get a complete list through, figure out what its minimum max is. We did this outside of the for loop because we only need to do this once. We don't need to continually figure out 3,597 times what the minimum and maximum is, right? And then we jump back into another for loop and do another set of operations. And this might seem like, oh my God, this is so much for the computer to do. This is what happens in programming all the time, right? So we have for loops and for loops and for loops as we run through these lists of operations, okay? So these are all lists within lists within lists of commands. Okay, so how are we doing? 6 minutes in? Okay, so the next part of this is we now have this numbers I, but we want to use this in our class, right? So in fact, maybe what we should do, let's do just one more check here. So let's say, now that we have that, let's say the number. And this this is debugging in a way, right? So we want to test to see if these numbers are what we think they are, right? So this looks pretty good. So originally we said it was 50,000, and we said let's map it to the new minimum, and the new minimum is 10. So you can see we get all these little incremental values. All right, now I have to scroll forever. So we'll leave that there. Oops. Okay, so how do I get this thing called, this list of numbers, the number, how do I get that into the bubble, right? So I think that's kind of funny. We put it into the constructor bubble, right? So we have this variable called R, and we're using it for the size of the ellipse, and we're declaring what it is here. Well, what we need to do is have this program reach back over into the bubble and put that number in there, okay? So what we do here is we first of all have to tell it what kind of thing we're going to use. So we have to say if it's an integer or whatever. So in this case, it's a float. And we've already used the variable R for like the radius. I guess it could be the diameter. But here we're assigning that it's going to be random, right? So what we're going to do actually, and this is kind of a standard convention, is I put underscore R. I could also do, maybe we should do it this way, temp R. Okay, and I'll do that here, temp R. So we have a floating point number that we're going to put in this every time we create a bubble, and we're going to say when you need to run the run function down here, that value is going to come from the constructor, right? So R is going to equal whatever this temp R is. And some people, you saw that I used this little forward slash. Some people do this as their way of whatever the name of this variable is, they put the same thing up here, but with the underscore in front of it, okay? So it could be either one of those. So let's go ahead and run. All right, so already we have a problem, right? So it says the constructor bubble does not exist. It just means that when we tell it to create a bubble, it doesn't know what, it's waiting for us to put a number in here, right? It would be just like if we say ellipse, but we didn't put any of these values in here, then it wouldn't, or if we did random, random, okay, if we had something equal random, it wouldn't know what it is. It's even trying to help me out. The function random expects parameters like random float. So it needs something into its own little constructor, right? Its own little argument. So let's go back. So it's waiting for us to put a number in there. And now all we need to do is say the number I. So we now have a list for it to access. And every time it creates one of these, it will get the first one and the second one and the third one and the fourth one as it runs through. And it feeds that. And now that's part of that, whatever that bubble is. Okay. So I can see some variation in there. I'm not totally set on the size or the scale. Let's change this background. It's actually a bad color. Okay, so it's a little bit easier to see. We also have that number R that we could use. We could also use that to determine, say, the fill itself. So maybe let's just say R plus 100. That's okay. And right now it's still too dense, and I'm also going to change. So one thing about this is my intent is to have this run full screen. So let's go back and change that. All right, so this is a little bit easier to see, but I still think some of these bubbles are too big in the relationship. But I'm starting to see some of what I want in this. Let's go back to the opacity too. It's a little. Would we make that random 10? Let's just replace that. Let's say 35. Oh. All right, so right now we're just dealing more with the aesthetic side of this. And let's maybe put this. Okay, so you can see we're getting, that's a little bit better. We can see the red ones starting to show up. I like that the bigger ones show up nice and red and the others are kind of gray. Let's maybe tone that down a little bit. And at this point we're playing with aesthetics. We have our code working. The last part about this as I look at it, I think that the max, let's make this smaller. I want those to be pretty little, and I think these are too big. Okay, so I now have this random sea of ellipses. It looks pretty random, and again, so this is just an example. I think this is like on the beginnings of where we might go with this. But it is a data visualization from a set of numbers that you might think are just random set of numbers. They're actually, I went and hunted this down because I was curious what kind of data I might use for an example. So you can see these little relationships to these sizes. These are actually the salaries for Virginia Tech faculty that make more than $50,000 a year. Obviously, I'm not going to tell you names or anything like that, but this is basically a data visualization of the faculty budget for Virginia Tech. I can think of lots of different creative ways that we could start to examine this differently. Like right now, the bubbles overlap with each other. What if it went through and it packed all these bubbles in tight to each other and it started with the largest values first and the smallest values here? We would in essence see an ecosystem of those data values, those salaries, across the board, right? We've also set it up with the color in such a way that the larger ones stand out again, but they're still transparent so that we can see these others in here, right? Oops, sorry about that. How are we doing? 13 minutes. Okay, let us review. We've created a list that we're going to populate with data. We've created our own custom function. And you can create as many of these as you want. Okay, this is a good way of like organizing your data. Sometimes it's better to put it in a class. I've done lots of programs where I felt like it was just as helpful to do this. You can create as many tabs as you would want. So what we could do is create another tab here and pick all this code and put on it and just call it the load data tab. And it's just a way of organizing your strings of your lists of instructions, right? So we loaded a table, went and got a row within that table, and then got a number, went and got a number within it. Cleaned the data, cleaned up the data the way we wanted, and remapped those values to something that was usable for a visual representation of that data. Okay. Alrighty, I think that's the end. Let me know if you have any questions.